All right, today we are going to build a complete AI red teaming toolkit, and we're going to do it from scratch. So if you've ever been curious about how the pros find and exploit the weaknesses in AI models, you are in exactly the right place. We're going to break it all down, starting from the very beginning.
So, what's the big question here? How do you actually go about testing an AI to find its breaking points? I know it sounds like this huge, complicated challenge, but the core idea behind it, it's surprisingly simple.
I want you to think of it like this. You've just built a brand new, high-tech robot bouncer for the hottest club in town. Your AI, that's the bouncer. Red teaming, then, is basically you hiring a team of absolute tricksters to try every move in the book to sneak past it. And today, we're building the gym where that bouncer's going to train.
So, let's get right to it. We're going to break down exactly how to build this training gym right on your own computer. We'll start with the big ideas, the tools you'll need, and then we'll put all the pieces together.
Now, to make all this make sense, we're going to use one simple analogy for this entire explainer. I want you to think of your computer as a kitchen, right? In this kitchen, a program is just a recipe. The command line, that's just how you give orders to the chef. And folders are just the cupboards where you keep everything organized. Simple.
Every good kitchen needs the right tools, right? So let's stock up our coder's kitchen with a few must-haves for building our testing system. And hey, don't worry, they're really not as complicated as they might sound.
First up is the command line. You might also hear it called the terminal. Forget about icons and clicking with a mouse for a second. This is your direct text message line straight to the computer's brain. You type a command, you hit enter, and the computer does exactly what you told it to. It's fast, it's powerful, and it is the foundation for everything we're about to do.
And look how easy these commands become when we think about our kitchen. Typing CD, that's just you walking into a room. LS or dir, that's you just looking around to see what's inside. And mkdr, well, that's you literally building a new cupboard to store stuff in. See, it's pretty intuitive when you look at it that way.
So, where do we get our recipes? We get them from GitHub. Think of GitHub as a massive public library, but for code. And a command like git clone is basically you walking up to the librarian and saying, "Hey, can you send me a complete copy of that project?" And poof, it arrives neatly right in your current folder.
Okay, now that we have the recipe book from the library, let's kind of flip it open and look at the paperwork inside. Every single coding project has a bunch of different files that act as instructions for everything, from the shopping list all the way to the final cooking steps. So here's how each file fits our kitchen analogy. The pie file, that's the actual recipe written in Python. A TXT file is basically your shopping list of all the ingredients you're going to need. The Docker file, these are the special instructions for packing the whole kitchen into a box. We'll get to that in just a second. And a YAML file, that's like a really structured recipe card with super strict formatting rules. Okay, this next part, this is where the real magic happens. We're going to talk about a tool called Docker. And it solves one of the biggest, most annoying problems in coding, which is the whole, well, it worked on my machine thing.
Docker is like a magical shipping container. Instead of just sharing your recipe, imagine you could pack your entire kitchen, the specific oven you used, all the ingredients, the tools, absolutely everything, into one single box. Then you can send that box to anyone, and when they open it, it just works. Perfectly. Every single time. No more missing ingredients. It's a game changer.
And this all breaks down into two main steps. First, Docker build uses those instructions to pack up the magic box and gives it a name. In this case, Red Team. This is the assembly step. Then, Docker run actually opens that box up and turns everything on. And that little -p flag, that just creates a window so we can see what's happening inside from our own computer. So we've learned about the kitchen, the tools, the recipes, and the magic box. Now, let's put every single piece together and see our AI Red Team Toolkit in action. This is the fun part. This flowchart right here is the entire workflow, from start to finish. You open your terminal and you walk into the project folder. You tell Docker to build the kitchen. You tell Docker to run it. Then you just open up your web browser to a special local address, and boom, you get a full report on the AI's vulnerabilities. And here is the real payoff. This is what makes it all worth it. Once everything is set up for the first time, this entire process, going to the folder, building the container, running the test, can be done with one single powerful command.
This is it, the one-liner. And all those double ampersands, the and, all that means is, and then do the next thing. So you're just telling the computer, go to the folder, then build the box, and then run the box. You type this one line, you hit enter, and your entire AI testing suite just spins up, ready to go.
So let's just step back for a second and see what you've actually got now. It's way more than just a program. It's the understanding of how all these pieces fit together. The kitchen, the recipes, the magic box. You have a complete working AI testing system that you can now run, you can modify it, all built from the ground up by you.
And that brings us to the end. Your AI testing kitchen is officially built. It's stocked, it's ready for action. So the only real question left is, what recipe for chaos are you going to cook up first?